So we had a really fun, a keynote speaker this morning for this conference that we were co-chairing, where Marta had talked about just sort of a lot of the, unknown unknowns when it comes to AI, deploying AI systems and things that issues that come up around trust and unconscious bias and all that. So I'm kind of curious, how do you think about how we should, confront those issues as we think about AI systems deployed in the real world?
Oh God, yeah. Her conversation was fascinating, right? Should we put a black box in cars? It was really interesting in some of the research she's doing. So we look at it through a lens of we can put as much trust into the system as we can, and the way we try and attack that is before we actually implement AI. And I'm talking about what we do inside of our own walls, not just how we help other customers. We look at 5 questions. Right? And those 5 questions help us determine, at a minimum, are we doing everything that we can to make it as ethical and as moral and as right in our AI decision making as we possibly can do. And those 5 questions are we even asking the right question? Right? Does the question make any sense? Should we be asking it? Are we using the right kind of data? Right? Bias is a huge deal. You know that. And if there's an inherent bias, which there always is because there's humans involved in making sure that data is clean and ready, how are we at least mitigating as much as we can? Is the analysis accurate? Are we looking at it objectively? What do we plan to do? How are we interpreting those results? And then finally, based on the decisions, what are we making? Like, how are we making decisions based on the insights? And at least what we found is that's helping us get more and more trust into the system because at least we know all of the input was as clean as it could be and as solid as it could be, right? Garbage in, garbage out.
Right.
We're trying to look at it from the other method, right? Gold in, hopefully more gold out.
Yeah. Yeah, it's interesting because you mentioned how you have these internal ways that you kind of confront how to think about these pretty tough challenges internally.
Yeah.
And I feel like that's probably something that every company that wants to adopt AI has to deal with, right? So I think how has incorporating AI technology adapted how you guys think even operationally around how to build a business around this novel technology?
Oh gosh, great question. So what we're doing internally is we've got a lot of different POCs in addition to some full deployments, right? So we've actually tested AI inside of our factories to help do defect detection, right? We're actually a massive manufacturing company. We build a lot of chips, right? And it takes a lot of human ingenuity and understanding to look at those and help define defects. Adding computer vision has really helped cut down on some of our factories, which is cool. We've implemented it in even some of the back end processes. So for us, it tends to be more on the operational costs. Yeah. How can we help reduce operational costs and put more money into the research and development and the innovative side and less money into the how do we make sure our business is running as efficient as we can.
Yeah. I love the recursiveness of that, by the way, building hardware that enables AI and then reapplying AI to build better hardware.
Exactly.
That's amazing.
Yeah, exactly.
So how do you guys just think about kind of use cases, right? I think we're in this really interesting time when it comes to AI. AI can do everything, but you obviously have to pick what the right sequences. How do you guys think about use cases that excite you?
So it kind of depends on who you talk to, right? Intel's a really big company. If you talk to me, the use cases that really excite me and I love working on are more of the social good ones, right? So I spend time with the Red Cross and with companies that are trying to do really innovative things in medical to make people's lives better. We've got folks that are really passionate about making business better, right? And they spend a lot of time with FSI and with oil and gas and looking at how do we automate, preventative maintenance, for example. How do we help oil companies scan their lines and look at their rigs in the ocean and understand what could fail before it'll fail and help prevent big time issues, both from a cost perspective and an environmental perspective. So we kind of look at it based on what problems can we solve and what are our customers really trying to tackle today and then get engaged at that level.
Tell me more about that Red Cross example. I'm kind of curious, how are they thinking about employing AI?
Well, you'll have to stay tuned because we've got some really cool news coming out about that one. Yeah. But I mean, you can think too, like what we're doing with TrailGuard. Have you heard of this one?
No,
it's kind of a similar idea, right? How do you get AI into an environment where your power's probably not super accessible, there's not a lot of connectivity, and you want to go in and really help make a difference. So TrailGuard is this little tiny camera that has a couple of years of battery life, and it can distinguish between wildlife and poachers, right? So if you think about, the Sahara Desert and trying to help prevent poaching, you're going to have lions and tigers and elephants walking in front of your cameras, and you don't want to take up battery life by having your camera turn on, send something back through a satellite and say, yeah, it's just an animal. This is good. We want animals there. You want it to know and turn on only when there's a human where that human shouldn't be. Yeah. So TrailGuard's doing some really cool stuff, actually with the Movidius VPU in it, that's got super low power, actually allows them to extend battery life so that you don't have to send people in, every couple of weeks or every couple of months to change the battery out.
Yeah, it's interesting, right? I think when people think about hardware, new hardware solutions for AI, a lot of attention, rightfully so, on the training side, but actually inference is just as important, having new hardware for inference, because
exactly.
In examples you highlighted where you have something that's not connected to a power outlet, right? I think energy efficiency and things like that matter a lot. How do you guys think about that market, the inference market?
Oh, so we actually are looking at the inference market as being a lot bigger than the training market, right? Because once you train models, it's iterative after that, and you really want to deploy it, and when you deploy it, that's where you're going to learn. So we see inference at the edge as being a huge opportunity. Vision's obviously big right now, right? And helping people protect their homes, right? Who's coming in and out, only unlocking the doors for people that make sense. There's a lot in terms of speech recognition, right? With the Alexis of the world and the Siris and the Google Homes, a lot of that natural language detection. But then what gets really cool is when you combine all of that together, right? And you get inference chips that can run multi-model, all parallelized in a low watt solution, so that you can truly make it easier for people to live, right? Whether that's in a business setting and you're inside of a conference room and it's dimming the lights because you're not in there, so it's saving energy, or you're in a home setting and it's making sure your 2-year-old isn't running up and turning on your stove.
Yeah, it's exciting. I think that the inference market in general is exciting. I think the edge, the role that edge devices are going to play in it is going to be pretty huge. I think there's another thing that it hints at as well too, which is privacy issues when it comes to data and AI. And I think inference at the edge kind of unlocks new capabilities on the privacy front as well too. So I'd love to kind of hear how you guys think about that.
Yeah, so we're big believers in moving the compute as close to the data ingest as possible, right? Because as soon as you can run the ingest with where your data is being created, you don't have to send it anywhere. And the less distance in that data computation, the less attack surface. So we think that the more we can move it out towards the edge and the closer we can get to where people actually want their insights delivered, the better it's going to be for security, for privacy. We don't have to bring anyone else into the mix, right? A lot of companies are running services through the cloud, which is fantastic. It's a great infrastructure, but you want that actual solution deployed at the edge so that you're not adding complications and attack layers in your data.
That's great. And I guess to close up, just some parting lessons, I guess, as you've worked on this as a pioneer in the field of AI, particularly with this hardware component with the business that you guys have in Intel. Any kind of learned lessons over the recent years as you go to market with these new technology?
I think the biggest one is that we've had solutions in market from a hardware perspective that have been there for years and they've been good enough, right? It's getting us to where we are today, which is huge advancements, huge leaps in both training and inference, and even just moving along classical machine learning. But I think as we're going into kind of this next phase and getting bigger models, billions of parameters, trillions of data inputs, I think we need to rethink how we're looking at hardware and what sort of underlying technology, what sort of underlying memory, access to storage is really going to be available so that all of the cool stuff that people are thinking about, all of the innovation can actually happen, right? You've got to have the compute, you got to have the software, right? Those two can't get decoupled, but you've got to have both to really unlock things like GPT-2 and whatever else comes after that.
Right. It's a holistic problem.
It is a holistic problem, without a doubt.
Right. Well, thank you so much for being part of this.
Thanks you.